you doing? This is Coach Harris. Beautiful fall day, September 17th. Wanted to just help you guys out that are maybe distance learners or at home. Maybe need a little video on some stuff. So I want to backtrack about 3 or 4 weeks, and we were talking about functions, okay? Whether or not something's a function or not, and then also maybe a little bit of domain and range if we get a chance to, but definitely we'll start with functions. So let's go back to something that we know. Almost everybody knows how to graph. Okay, so when we're dealing with a graph, it's actually a Cartesian coordinate plane. You have x-axis and you have a y-axis. Remember, the x-axis is also the horizontal axis. Okay, the y-axis is the vertical axis. Okay, now how does this work? Remember, the x value is always listed first and the y value is listed second in an ordered pair. Okay, so just a little something to know about right there. So if I needed to plot points, let's say I wanted to plot the point 3, 4, I would start at the origin, 0, 0, I'd move 1, 2, 3 to the right and up 4. This is the point 3, 4, okay? So something to know right there. So again, this is basics and we want to get to functionality, okay? So how do I tell if something is a function or not based on the graph? Okay, first question. Based on the graph, is it a function or not? Okay, is the graph a function? So I'll use a different color here for this right here. So let's say I've got a graph of something that looks like this. Okay, we know this to be a line or a linear maybe function, whether or not we determine it to be or not. So whether or not a graph represents a function or not is based on what we call the vertical line test. Some people maybe have been told at times past the pencil test, where you take pencil and roll it across your paper. Well, I don't have paper here, and if I were to roll a pencil, we wouldn't see it very well. But let's say I took my arm and I went vertical with my arm and I went left to right across the graph. Okay? If my arm hits that graph in 2 or more points, it is not a function. Now listen to what I'm saying. If I went across here and I said stop, boom, and I hit it at 2 points on the graph, automatically not a function, okay? That's called the vertical line test. Now, this particular graph, this particular representation, of course, it's got the arrows on the end. We don't include the arrows. The arrows just imply that it keeps going and going and going. So if I were to go here and I say stop, it only hits in 1 point. If I go again, stop, it hits in 1 point. If it only hits the graph in 1 and only 1 point, then it is a function. It is a function. So something to know about that. So in this case, this line is a linear function, or it represents a linear function. So what if I were to put up there a different looking graph, a different looking representation of data? So let me do something like this. Something like a circle, not a very well-drawn circle, but a circle nonetheless, okay? So if I were to start on this left side, I would maybe hit that point right there, but boom, I stop right here and I hit a point right there, I hit a point right there. Automatically, not a function, okay? So real key way to learn this is this. If I'm looking at a graph, okay, if my vertical line test hits the graph in 2, that's not 2, in 2 or more points, then it is not a function. If it hits the graph in 1 and only 1 point across the entirety of the graph, then it is a function. So what did we just do? We just looked at a graph and we asked ourselves, is the graph representative of a function or not? Okay? In the case of a circle, no. In the case of that first line, yes. What do we use to determine it? Vertical line test. Thank you.